Hello students, we have seen in the last session about the properties and the meaning of modular arithmetic. Now we are going to use those properties and see some more properties in this session. If you have any doubt in these properties or usage of modular arithmetic, post in the comments. Let us see some properties. Before going into the property, let me check whether you have understood the congruence. So, see 17 is congruent to which number modulo 5? How will you say this? 17 on dividing by 5 gives remainder, yes, 2. So, 17 is congruent to 2 modulo 5. Yes, now go to the next sum. 24 is congruent to which number? Mod 10. So, remainder is 4. And here 62 is congruent to which number while dividing by 12? That is mod 12. So, that is 12, 5s are 60, remainder is 2. We need only the remainders, that is in modulo we replace the remainders, keep that in mind, we replace, in general we replace the remainders, okay. So, 5 is congruent to which number modulo 3? 2. So, using these we are going to see some more properties of modulo operations. See, if I add some number, yes, let me take the simple number 2. If you add 2 both sides, we are going to see what happens to the congruence. So, add 2 both sides, add 2 both sides of the congruence equation. So, yes, 19, 17 plus 2 is 19, 2 plus 2 is 4, mod 5. For the same mod you have to check. See, 19 on division by 5 gives remainder 4. Yes, that is the right answer. So, the property is if A is congruent to B mod M, then you can say for any integer C, A plus C is congruent to B plus C for the same mod. C is an integer, okay. Then let us go to the next one. 24 is congruent to 4 modulo 10. Let us have subtraction here. Yes, say some other number, 3, yes. So, subtract 3 both sides. So, 24 minus 3 is 21, 4 minus 3 is 1, mod 10. Yes, 21 leaves remainder 1 on dividing by 10, that is also correct. So, we can say that if A is congruent to B modulo M, if A is congruent to B modulo M, then we can say that for any integer C, A minus C is congruent to B minus C mod M. Okay. Let us go check with the third one. 62 is congruent to 2 mod 12. So, we are going to multiply now, multiply both sides by, okay, let us take a small number, yes, say any number, let me take 4, okay, multiply 62 by 4, yes, 4 2s are 8, 4 6 are 24, so 248 is congruent to, let us check the congruence, afterwards we are going to write the symbol here. So, we are multiplying with 4, so multiply 2 by 4, we get 8 mod 12. Is it true? We are going to check. While dividing 248 by 12, yes, the remainder will be 8, 240 plus 8, so the remainder is 8. So, that is how we have got the property as if A is congruent to B mod M, then for any integer C, we can say that A into C is congruent to B into C for the same mod. Keep that in mind, for the same modulo. Now, let us go and watch the next one, which says that 5 is congruent to 2. That means, on dividing 5 by 3, we get the remainder 2. Now, let us raise the power, that is exponentiate, raising the power to 2. So, 5 power 2, here 2 power 2, mod 3. See, 5 power 2 is 25. Let me check. 5 power 2 is 25. 2 power 2 is 4. See, whether they are congruent, we are going to check. See, 2 power 2 is 4, which is congruent to 1 modulo 3. So, 25 on dividing by 3 gives remainder 1, which is the right answer. So, on exponentiating, we can say that the exponents will never change in the congruence. That is, raising the power will not change the congruence. So, adding a number, subtracting a number, multiplying by a number or exponentiating by a number, both sides will make no change in the congruence for the same modulo. So, keep these properties also in mind in addition to we have learned whatever we have learned in the last session. Now, we are going to enter into the exercise. Exercise 2.3. First sum goes as, yes, what is the first sum? Find the least positive value of x. Find the least positive value of x for the following. So, first one, 71 is congruent to x mod 8. So, we know so many meanings for modulo. Now, we are going to apply any one of them which is very much suitable. So, if 71 is taken, we are going to replace 71 by the remainder on dividing by 8. So, if you divide 71 by 8, 8 8s are 64, remainder is 7. So, remainder can be replaced for this. So, 7 is congruent to x mod 8. See, we have got a number 7 which is less than this modulus. So, that should be the least positive value. So, we can say that x is equal to 7 because so many solutions will be there as we have learnt already. So many solutions of x will be there. That is, by adding 8 we will get the other solutions. But here in this sum we need only the least positive value. So, we leave here. Let us go to the second sum. That is 78 plus x is congruent to 3 mod 5. Now, we have learnt a property that subtracting both sides, yes, will never change the congruence. So, we are going to subtract what number? Let us subtract 3. So, subtract 3 both sides. So, subtract 3 both sides. We have to make it both sides. So, 78 minus 3 is 75 plus x is congruent to 3 minus 3 is 0 mod 5. So, what does it mean? 75 plus x is congruent to 0. Here also we can simplify again. While you replace 75 with the remainder on division by 5. What is the remainder by 5? Yes, 0. So, 0 plus x is congruent to 0 mod 5. That means 0 plus x means x is congruent to 0 mod 5, which means x is congruent to 0, that says x is a multiple of this modulus. So, x is a multiple of this modulus, which means x may be 0, 5, 10 and so on. But we need the least positive value. If you take 0, that is not positive. 0 is neither positive nor negative. So, we have to move to the next one. So, let us go take 5. So, x is 5. Okay, let us go to the third sum, which goes as 89 is mod congruence x plus 3 mod 4. So, see, 89 is congruent to x plus 3 mod 4. Here we can subtract both sides. Yes, what shall we subtract? Yes, 3. So, we shall subtract 3 both sides. That means 86 is congruent to x. 3 minus 3 will be 0. So, we leave that. 86 is congruent to x modulo 4. We can replace the remainder of 86 while dividing by 4. Yes. So, if you divide 86 by 4, 86 divided by 4, you get 2 4s are 8. So, 6. So, here 1 4 is 4, remainder is 2. We have to keep the remainder in mind. So, remainder is 2. Replace that. So, 2 is congruent to x for the same mod 4. We can read the other way also. X is congruent to 2 mod 4, which means x is congruent to 2 means x is 2 more than the multiple of 4. So, x is 2 more than the multiple of 4. So, we can say that x is equal to 4k plus 2 multiple of 4 plus 2. So, if you substitute 0, 1, 2, 3 etc. for k, we will be getting the values of x. First, let us substitute 0 in the place of k. So, 4 into 0 becomes 0, 0 plus 2 is 2. So, if k is 0, x is 2. This is less than 4. So, we stop here. As this is a least positive integer, x is equal to 2 is the answer. Now, let us move on to the next sum. Yes, let us go to the fourth sum, which says 96 is congruent to x by 7 mod 5. So, here in this sum, we have to be careful with this number. So, see, if we start a is congruent to b, we will be saying that a and b are integers. So, this x by 7 should be an integer. So, keep that in mind, x by 7 is an integer. Okay. Then let us proceed using the properties. So, what property shall we use? Yes, in the denominator we have 7. What shall we do? Multiply both sides by 7. Yes, you are right. So, multiply both sides by 7. So, 7 into 96 is congruent to x mod 5. Note, x by 7 is an integer. Okay. So, multiplication by 7 with 96 is somewhat tedious. Now, let us go and use our trick, that is, what is 7 congruent in mod 5? 7 is congruent to which number? Yes, remainder is 2. What is 96 congruent to? In the same 5 mod. No need to divide by 96. So, see the unit place. It is 6. So, if you divide 6 by 5, the remainder is 1. So, do like that. Okay. So, it is congruent to x mod 5. Multiply 2 into 1, 2. So, x is congruent to 2 mod 5. Since we need the smallest, that is least positive value, we will be stopping at 2. See, we have to stop at 2, but we have to take note that x by 7 is an integer. So, if you substitute 2 in this place, it comes as 2 by 7, yes, which is not an integer. So, what should we do? So, we have to move on to the next number, which is congruence to 2 in the same modulo 5. So, how will you get it? Yes, moving forward means adding this modulus to that particular number. So, we can say that adding 2 with 5 we get 7. We have to check here. So, 7 divided by 7, yes, it comes as an integer 1. So, x is equal to 7 is our answer. Keep that in mind. We have to check whether we get the integer answer. Okay. Let us go to the next sum. Fifth one, 5x is congruent to 4 modulo 6. Yes. See, what does it mean? 5x is congruent to 4 modulo 6. So, let us do the sum in two ways. Shall we? Yes, you can follow your own method. You can choose any of the method. Okay, see, 5x is congruent to 4 means 5x minus 4 is a multiple of 6, that is 6k multiple, integer multiple. So 6k. 5x minus 4 is 6k. As we have changed the modulo into equal to sign, we can proceed as linear equation. 5x is equal to 6k plus 4, that is adding both sides 4. This is simply a linear equation, or x is equal to 6k plus 4 by 5. Now you are going to put values of k. So k should be starting with 0, you have to give values. If k is 0, what happens to x? Yes, say substitute k as 0, 0 into 6, 0 plus 4 by 5, 4 by 5. So we need no fraction, no rational number. So we need an integer. So x is 4 by 5, which is not accepted. We have to move on. If k is equal to 1, what happens to x? Substitute k as 1. So 1 into 6 is 6. 6 plus 4 is, yes, 10. 10 by 5 is 2. Yes, x is an integer now. So let us take the answer as x is equal to 2. Okay? Yes, you need the other way. Yes, we will be doing. Yes. See, the alighter, one more method is there which came to my mind now. That is 5x is congruent to 4 mod 6. Let us enjoy the property, that's all. Now 5x, here mod 6. See, this is 5 is, yes, very good, one short of 6. So let me name this as minus 1 into x, which is congruent to 4 mod 6. Can you understand? Now we have replaced in the backward cycle. 5 is replaced with minus 1, as this is modulo 6, that is subtracting, we get this number. Okay? See, minus x is congruent to 4. What shall we do? We know that multiplying by a number both sides will not change the congruence. Multiply both sides by, yes, minus 1, that is it. So minus 1 into 1 plus 1 x is congruent to minus 4 mod 6. Yes, shall we stop here? Is x equal to minus 4? Shall we stop there? Yes, we should never end with minus numbers, negative numbers. Our answer should be positive, least positive. That is the first topic itself. So what should we do to make it least positive? Moving forward, that's all. Add this modulus, yes, 6, very good, you have understood. So is equal to, yes, 6, add 6 to this minus 4, you get 2. So 2 is the least positive integer. Whichever method you like, you can follow. Okay. Okay, have you understood all these? Let us move on to the second one. If x is congruent to 13 modulo 17, it is given in words. First let us write in the modular statement. See, if x is congruent to 13, yes, 13 modulo 17, okay. Then 7x minus 3, 7x minus 3 is congruent to which number? Which number? As already we have x here, I am going to write y. Which number? Modulo 17. Have you understood the statements first? If x is congruent to 13 modulo 17, then 7x minus 3 is congruent to which number? Y? Why I have introduced y here? Because already x is available. So we should not repeat. So we are going to take y or any other initial use. Okay? Mod 17. Okay? See, x is congruent to 13. So we are going to replace the congruence here. So 7 into what is in the place of x? We are going to replace 13. So minus 3 is congruent to y mod 17. So we have changed this statement like this. Instead of x, we have substituted 13. Okay. Now multiply 13 and 7, it goes as 91 minus 3 congruent to y mod 17. You have to follow mod 17 till you remove this congruent sign. Keep that in mind. Long as you write this congruence, you have to write this modulo. Okay. So, 91 minus 3 is 88 is congruent to y mod 17. So, what does it say? 88 on dividing by 17. What remainder it gives? Yes, now let us check. 88 divided by 17. 17 5s are 85, remainder is 3. So, we can replace with the remainder. So, 3 is congruent to y mod 17. Now, the answer is there. Yes, y is congruent to 3 mod 17. So, is the answer. That number is congruent to 3. That is 7x minus 3 is congruent to 3. Let us go to the next sum. Solve 5x is congruent to 4 modulo 6. I am not going to do this sum because we have already done this sum in the first subdivision itself. But we have there got only one solution. You are going to get all the solutions now. By going forward, you are going to get this is a follow up for you. This is a homework for you. Now, let us go to the next one. Fourth one, which is solve 3x minus 2 is congruent to 0 mod 11. So, this is our fourth sum. So, 3x minus 2 is congruent to 0 mod 11 to 0. If you say congruent to 0, what does it mean? It means that yes, it is the multiple of this modulus. So, 3x minus 2 is not congruence, is the multiple of 11. So, 11k, multiple of 11 where k is an integer. So, 3x is equal to solving linear equation, we are going to follow the same method 11k plus 2 and x is equal to 11k plus 2 by 3. So, we are going to substitute the values for k from 0, 1, 2 and on and find the value of x till we get an integer answer. We have to do this. See, if k is equal to 0, what does x mean? So, k is 0. So, 11 into 0 is 0 plus 2. So, 2 by 3. So, 2 by 3. Yes, why? Why it is not the answer? It is not an integer. Keep that in mind. It is not an integer. So, if k is equal to 1, let us try 1 into 11. Yes, 11 plus 2, 13. So, x is equal to 13 by 3. Yes, which is not an integer. Let us move on. If k is equal to 2, what happens to x? Yes, see, k is 2. 2 into 11 is 22 plus 2 is 24 by 3. Yes, that is 8. So, we have got an integer. So, let us stop here. X is equal to 8. But we have to find all the solutions. We have to find, there will be so many solutions as we have already seen. So, how will you get the next solution? Yes, next solution means moving forward, that is adding the modulus. Modulus is 11. So, add 11, add 11. So, get so many numbers. Okay. We can get the previous numbers also, but we leave here because we have got at least 3 numbers. Okay. So, let us move on to the next sum. Yes, that is a word problem. It is not at all a problem. See, what is the time? 100 hours after 7 a.m. Oh, it comes the clock. Yes, now 7 a.m. is the time we start. Okay, let me see. We are going to choose the digital clock now. Shall we choose? Because all around us became digital. So, we are going to choose digital clock for this sum and do this sum. I will say y. Okay. 7 a.m. that means a.m. means we have to take that number as such. So, 7. What is after? What do you mean by after? After means moving forward. Yes, going up, that is adding up. What number? 100 hours. So, we are going to add 100. What is the time? So, time is asked. So, time should be in mod 12 or 24. Shall we take 24? Because if you take 24, we will be saying whether it is AM or PM. That will be easier for us. So, we are going to take it for 24. Okay. See, 100 plus 7 is 107 is congruent to x mod 24. This is very simple. You are going to divide by 24 and get the remainder, that is it. So, 107 divided by 24. So, 24, 4s are 96, 11 is the remainder. So, divide and see, 11 is the remainder. So, x is congruent to 11 mod 24. So, as it goes for mod 24, that is digital time, we can say whether it is AM or PM. Yes, say AM or PM. 11, it is before 12, so it is AM. So, forenoon or 11 AM is that time. Okay. Let us do the next sum now in the class. See, prove that 2 power n plus 6 into 9 power n is always divisible by 7 for any positive integer n. See, let me write 2 power n plus 6 into 9 power n is always divisible by 7. So, we are going to get the mod of 7. Congruence to which number? We do not know the congruence. We have to prove that it is divisible. So, we have to prove that this is 0. Shall we? Yes. So, I am going to give you a simple trick to work out this sum. See, this seems to be so, yes, complicated, but it is so simple. So, 2 power n plus, see, mod 7 and this is 6. What will we do? Can you recall? Yes, we will be, yes, coming backwards, that means minus 1. 6 is replaced with minus 1 for mod 7. So, just think it off. Okay. Then 9. 9 is replaced with the remainder 2. So, 2 power n. So, as the 9 is given the exponent n, we have to give the same exponent here for the remainder also. Okay. So, it is congruent to x mod 7. So, we have just used the properties. Go and check with the properties at home. Okay. Plus into minus 1 is minus. So, 2 power n minus 2 power n. Yes, we have got the answer mod 7. So, we have proved that this is divisible by 7. That is leaving no remainder. Okay. Hence the proof. In this class, we have learnt some properties of modulo operations and we have dealt with the sums involving those properties. Now, in the next session, we will be meeting with a completely new concept of mathematics. Thank you, children.